Hi, and welcome to Group 15's presentation for our Advanced Software Engineering project. For this presentation, we were tasked to discuss our Xtreme Programming implementation, our complex computer science component, and our quality of code. In the Xtreme Programming section, we will discuss our diary, our pair programming implementation, the refactoring of our code, and our test-driven development. In the complex computer science component, we will discuss the publisher-subscriber model and also our journey filter system. For our Xtreme Programming implementation, we kept a well-documented diary, we implemented pair programming, we also refactored our code regularly, and used test-driven development. For our diary, we initially needed a well-planned-out project. You can see here the different tasks broken up between different teams. Later, we will show how these teams were broken up. Each task was given a timeline, and contingency dates were added to the end in case our project plan was too ambitious. Here, you can see an example of our pair programming implementation. The idea here was that one group member would have at least 1 week's experience with the component. After 2 weeks, this pair member would move on to the next component or next team. This ensured every team member worked on every component in our project, meaning that if there was an absence, we did not suffer as everybody understood all of the components. The project could continue to move forward. This table demonstrates how group members would move around each pair from week to week. For our refactoring, we ensured that our code was continuously optimized and changed to provide the same output. During our continuous integration to master, ESLinter was used to ensure code synchronization and continuity between files. Team meetings were also held so that each member was up to date with the current state of the project at all times. This again follows on from our pair programming concept, keeping every team member up to date on every component. For our test-driven development, we mainly focused on our backend. We implemented test-first development for our backend development on our endpoint requests. This ensured that our backend functioned correctly and we did not break our product. For front-end React Native testing, we used simulated customer tests on the application to test React components. This could be done in real time and the results could be seen immediately. For our complex computer science component, we attempted to implement PubSub into our app. This became a research and evaluation method. To replace this complex computer science component, we used a journey sharing filter, or an electronic XOR gate design structure, as our team is from the CD engineering stream.
So publisher subscriber models are basically a form of a message queue system. They allow asynchronous communication between message producers and consumers. So the plan for this project was to use a publisher subscriber model to stream relevant data between clients in an efficient manner. The basic idea was to have various producers and consumers. For example, an example producer might be a person who's creating a journey, so they would create that journey and stream it to the publisher subscriber broker, basically the server machine, and it would be streamed to a particular topic, which then a consumer could subscribe to a specific topic. So an example of a consumer may be a client who is searching for journeys in a particular area. They might consume relevant data to do with that. So that was kind of the way that we intended to use a publisher subscriber system in this project. The kind of problem with this was a couple of things. Basically, there was no publisher subscriber producer or consumer libraries or services that were compatible with React Native. This seems to be to do with the fact that they need to use like TCP connections, and it's just not really compatible with like a mobile application. So we kind of discovered this through research after a couple of weeks of attempting to implement it, thinking that it would work. So the PubSub services are usually used for server-to-server communication rather than server-to-client communication, which is what we wanted to do, so we ended up abandoning the idea eventually.
Our team implemented a search filter in the app's Journeys page. This filter was based off of our electronic engineering backgrounds. We combined our knowledge of electronics and computers to create a great filter for our Journeys page. The user has the option to filter the journeys on the Journeys page. The user can filter by method of the journey, this being walking, driving, or cycling. They can also filter by distance, price, and journey creator rating. The user can choose to show one-off trips only or daily trips only. When the Apply button is pressed, the Journeys page displays the journeys that satisfy the filter values. The filter is based on an electronic filter system made up of basic logic gates. Each filter value gets passed through an AND gate with the relevant value from the database. If both values are the same, the gate output will be high. The output of the gate gets XORed with the inverse of the original signal from the filter value. This means that if the filter is left empty, journeys will still appear on the Journeys page. The output of the XOR is high when either the filter is empty or a value in the database has been found based on the filter value. The output of the 4 XORs get ripple ANDed together. The final output of the filter are all the journeys that meet the filter values. Our team had a set of coding standards that each member of the team had to use to make the linting process easier. We used ESLint as our linter, and we used the Airbnb rule set to check our code was in the correct structure and format across all files in the application. The Airbnb rule set is the current industrial standard when it comes to linters. ESLint provides a list of rules that can be configured as errors, warnings, or just turned off. Airbnb has configured those rules in such an effective way that it is used by many large and leading tech companies in the industry today.